We're now going to go over some facts about triangles, and then we'll use those facts to help us with the side-side angle case. Okay, so one fact that we've used quite a bit is that the sum of the three interior angles of a triangle is 180 degrees, right? All three of the angles add up to 180 degrees. Okay, and next one that you might not have thought about before, but it will probably make sense. If one of the three angles is greater than 90 degrees, so if you have an obtuse angle, then the other two angles must be acute. So if they weren't, you would have more than 180 degrees, which would be a problem. So if you have one obtuse angle, you can't have any more obtuse angles, or even a right angle. Okay. Here's a fact that's important about triangles. The sum of the two shortest sides must be longer than the longest side. So if you take the two shorter sides of a triangle and add them up, that has to be longer, has to be bigger than the biggest side. Okay, the next two kind of go together. The side opposite the largest angle is the longest, and the side opposite the smallest angle is the shortest. Okay, so big angle goes with big side, opposite, little angle goes with little side. Okay. For any angle A in a triangle, since A is between 0 and 180 degrees, sine of A must be between 0 and 1. So remember, for a triangle, right, we only have positive angles, and it has to be between 0 and 180. So if we think about sine are the y values. These are all positive. And we know 1's the biggest it can be. So for any triangle, if you have this an angle of the triangle, the sine of that angle must be between 0 and 1. Okay, and then it says there are always two angles between 0 and 180 degrees that have the same sine function. Okay, so and those angles would have the same reference angle. What we're saying here is, notice if we take any of these angles, like 30 degrees has sine of 1/2. Well, 150 degrees also has sine of 1/2. Sine of 45 degrees is square root of 2 over 2. Well, so is sine of 135. And sine of 60 is square root of 3 over 2, and so is sine of 120 degrees. So that's what we're saying. Okay, so now we're going to learn about solving the side-side angle case. Okay, so given one angle and one adjacent side, and the side opposite the angle. So we have one opposite pair and then another side. The number of possible triangles is either 0, 1, or 2. So sometimes you won't have any possible triangles. Sometimes we'll get exactly one, and sometimes we'll actually get two possible triangles. So first we'll look at the angle we're given. If it's obtuse, okay, then if A is longer than side B, then you'll have exactly one triangle and you'll be able to solve it. Now, if your side A is less than side B, then we have a problem and we have 0 triangles possible, and you would just say no solution. And the reason, if A is obtuse, then A must be the largest angle. And one of the facts that we just stated above, here in green, is that the side opposite the largest angle is the longest. And if A is the largest angle, then we need side A to be the biggest. So if it's not, if it's smaller than the other side you already have a problem. Okay. Now we're going to look at the case if the angle you're given is acute. Okay. Then you're going to fill in the law of sines here. Okay, so you're going to have A and sine of A, and you'll have little b, and you'll leave this saying sine of b. And then we're going to solve this for sine of b. So we'll cross multiply, and we'll say A sine of b equals little b sine of A. We'll divide both sides by A. So we're going to get sine of B equals B sine of A over A. Okay, and you'll actually plug this into your calculator to get a number. Okay, if that's bigger than 1, then we have a problem because sine can never be bigger than 1. Okay, so we get 0 triangles, and you would say no solution. If it's exactly 1, then angle B is a right angle, and you'll get 1 triangle. Okay, and you'll be able to find a solution. Now, if angle B is less than 1, okay, then we have a possibility we're either going to get 1 triangle or 2 triangles. Now, what we're going to do is we're going to take, so angle B will be sine inverse of that number you just found in the calculator, B sine of A over A. So that will give you 1 triangle, and you would work with that. The other possibility, you'll take 180 degrees minus the B you just found. And if that new B, if this works with the angle A you already have, so if that and the angle A you have are less than 180 together, then you get 2 triangles. So we'll work out some examples, but so we're saying if you have an acute angle A that you're given and you work out this sine of B and it's less than 1, sometimes you can get 2 triangles, and we'll show you how you do that. Okay, here we're going to use the test that we just talked about to determine how many triangles there are. So here we're going to look at angle A and first decide if it's obtuse or acute. So here it's obtuse, and this one's acute. So we notice here that we want to just check then, is angle A, or side A, the one that's opposite A, bigger than the other one? And it is, so here we'll get 1 triangle. Okay, and we could just go ahead and we're not going to here, but we could use law of sines to solve the triangle. So first you would find angle B, then angle C using the 180 rule, then little c using law of sines again. Okay, the next one we have little a equals 60, b equals 82, and a is 100. And here we notice that the side that's across from an obtuse angle is smaller than our other side. So that breaks the rule that the largest side is across from the largest angle. So this breaks the rule that the longest side must be across from the largest angle, so no triangles are possible. So let's say there are 0 triangles possible. Okay, now we get to the acute case. So we have little c is equal to 35, big C is equal to 40, and little a is equal to 30. So let's kind of draw out what we have. So we have this is 40 degrees, and this is 35, and this is 30. Now, so here's our opposite pair. So we're going to set up 35 over sine of 40 is equal to our other opposite pair, 30 over sine of A. So I know in the directions we're using the letter B, but it doesn't matter. We can use A here. So we're going to cross multiply and solve for sine of A. So we're going to have 35 sine of A equals 30 sine of 40 degrees. Now we're going to divide both sides by 35. So this gives us the statement that sine of A is equal to 30 sine of 40 degrees over 35. And that's something that we can put in our calculator. 30 sine of 40 degrees. Let's make sure we're still in degrees. We are. Divided by 35. Okay, and this is equal to, or approximately equals like 0.55. So that's less than 1. So here's the case where we could get two triangles, and here's how we determine if it's 2 or 1. So to find A, we're going to take sine inverse of this stuff, which in your calculator, you've already put that in. You're going to do sine inverse of answer, as long as you haven't done anything else in your calculator. So sine inverse of that answer. So we get that A could be, or one possibility for A, is that it's 33.4 degrees. Now, the other thing we're going to check is 180 minus 33.4. So that was 146.6. Now, here's the problem. If angle A is 146.6 and we still have to have 40 degrees, this can't be a possibility, okay? So if that worked, if that plus C was still less than 180, we'd now have to do two problems. We'd have two separate triangles, both with this information and then with different A's. But that one is too big with side C, or angle C, so we can only have this angle. So here we only get one triangle. But sometimes it will happen that you'll be able to get two.